Hey everybody, welcome back, and let's read about closures. The ability to treat functions as values, combined with the fact that local bindings are recreated every time a function is called, brings up an interesting question. What happens to local bindings when the function call that created them is no longer active? The following code shows an example of this. I don't think these examples do a great job of showing the complexity involved in closures, but I'm going to stop pretending that I know everything this book says and just kind of read it through. If we get to all the way to the end of chapter 3 and closures are not clear, maybe we'll put some definitions or something in. We'll figure it out. One thing I did do from the previous section is I wrote down this optional default arguments definition and kind of scraped together a definition of the optional default arguments that they. I guess it's optional arguments slash default parameters. So we'll say optional arguments default parameters. So cool. All right, closures. The following code shows an example of this. Editorializing comment, blah, blah, blah. It defines a function, wrap value, that creates a local binding. That's going to be this let local equal n. It then returns a function that accesses and returns this local binding. And what that means is that this function here, the arrow function, because it's created inside of the wrap value context or in its scope, it has access to that which is also in that local scope. So this local n is now, even though that function wrap value will end at a certain point, we still get access to that let local equal n, and that's what the closure is. If that definition confuses you, you're probably not alone. So anyway, okay, let wrap value of n, let local equal n, return a function where we basically just automatically return local. The reason I don't like examples like this is because I don't think that it's easy to misinterpret what's going on here, but that's okay. So on line 6 we say, cool, it doesn't explain it. So let wrap1 equal wrap value of 1. Essentially we're returning a function. So wrap1 is now going to be assigned to this function that's coming back, which has access to this local is equal to n binding. Okay, so we'll call both those. We get 1 and 2. We don't really understand what's going on yet, but we get the idea a little bit. This is allowed and works as you'd hoped, or works as you'd hope. Both instances of the binding can still be accessed. Okay, I guess that's another point to demonstrate, which would be if we were to console.log local, we're going to have a problem. If we console.log n, we're going to get a problem there too. Maybe that makes things clear, maybe makes it worse. Hopefully it doesn't make it worse. Okay. This situation is a good demonstration of the fact that local bindings are created anew for every call, and different calls can't trample on one another's local bindings. So again, instead of reading what happens after the code, I tried to explain it without reading the following text. So if nothing else, it's a, what would you call it? An allegory for reading everything first? Or like a warning tale? I'm not sure what an allegory is. Let's find that out. A story, poem, or picture that can be interpreted to reveal a hidden meaning, typically a moral, political one. Well, that doesn't seem to quite fit, but we learned a new word. So, all right, different calls can trample on one another's local bindings. This feature, being able to reference a specific instance of a local binding in an enclosing scope, is called closure. A function that references bindings from local scopes around it is called a closure. This behavior not, ooh, that sounds like a definition. So we'll say a function that references bindings from local scopes around it is called a closure. All right, so we'll say a closure, a function that references bindings from local scopes. You might want to put a little bit of this in here as well. This feature, say, being able to reference a specific instance of a local binding in an enclosing scope is called a closure. Oh. And we're just going to dot this. Excuse me, and all we're doing there is, our definitions aren't perfect, right? But what we're going to do is by the end of this book, or the end of the time that I've spent reading through the book with you, we're going to have a big list of definitions of words that, especially if you're a beginner, it's a good idea to just have those almost memorized. Certain things are going to be much more useful to memorize through practice, and certain things like, lexical scoping, that's definitely one where you want to just memorize that, because why not, right? So, well, why not would be because it's difficult and time waste, or not wasting, but it's time consuming. But so is all of programming, so that's no argument. This behavior not only frees you from having to worry about, none of these things free you from worrying about anything, but okay, so this behavior not only frees you from having to worry about lifetimes of bindings, but also makes it possible to use function values in some creative ways. Cool. With a slight change, we can turn the previous example into a way to create functions that multiply by an arbitrary amount. Okay, here we go. This is kind of the first time where a closure would start to make some sense. We've got a function called multiplier. It takes in a factor parameter. We're going to return a function that is going to take in a number parameter and return that number parameter multiplied by the factor parameter, which it has access to, this function right here, when I say it has access to, I mean this function has access to this factor binding through a closure. Okay, so we're getting a little closer to a definition that kind of makes sense. And if we run this, we get 10. It said we should. And if we change this to say something like, let's say, let thrice equal multiplier with 3, and then we console.log thrice on, I don't know, 16? Well, 6 anyway. And we run that, we're going to get 18, which is cool. Turn to arbitrary amount. The explicit local binding from the wrap value example isn't really needed since a parameter is itself a local binding. And this is their explaining kind of the problem I had with the initial example, which is this can happen, right? Where you're describing a principle and you use a simple enough version of it such that what you're actually explaining is also partially misunderstood as a different part of the language. And what we mean by this is exactly what they're saying here. The explicit local binding, this one up here, it already has access to that, right? Because we created it inside of it, and we're not really taking advantage of it. Whereas this multiplier one actually does start to demonstrate a use case that is, for which we do not have another solution, at least at this point. So, isn't really needed since the parameter itself is a local binding, right? So thinking about programs like this takes some practice. You can say that again. In fact, I will. Thinking about programs like this takes some practice. A good mental model is to think of function values as containing both the code in their body and the environment in which they are created. And this is a cool thing, right? Because it's like if somebody was trained in a certain, like, let's say, pottery approach, they create new like art or new work, but you can also kind of tell like a little bit of their training sometimes, and it's really only like the experts, the ones that have figured out everything. Why are we talking about pottery? Anyway, let's go back to the actual text. Thinking about programs like this takes some practice, so we now said that 3 times. A good mental model is to think of function values as containing both the code in their body and the environment in which they are created, yada yada, something about pottery. When called, the function body sees the environment in which it was created, not the environment in which it was called. This is huge. This is the whole lexical scoping versus, I think it's runtime scoping, or run. There's something about this that is a very key phrase. So we're gonna copy this. And we're gonna put it side note next to lexical scoping. We'll say when called, the function body sees the environment in which it was created, not the environment in which it was called. Cool. If it turns out that I'm mistaken about that, we'll go ahead and adjust it, but I don't think that I am. In the example, multiplier is called and creates an environment in which its factor parameter is bound to 2, as we can see here. Well, let's get rid of the extra stuff just because the rest of the description is not going to feature the random thrice code that I wrote. So there we go. Factor parameter is bound to 2. The function value it returns, and we know that it returns a function value because of the way that it's written. The syntax is a function, and so when it gets returned, this function definition is the actual value that the function is returning. So when we think of twice, twice is a function. We can prove this by console.logging twice. Let's go ahead and write console.log. We'll say definition of twice. We're going to do that thing that we did previously where we have console.log take in multiple arguments. And we're going to write twice, but we're not going to call it. We don't write that, we write this. And this is the actual definition of the function. So if we run it, we see that it actually outputs, and oh, how cool, it highlights it for us. But it tells us that, hey, this is an actual function definition, which is nice. Function value returns, which is stored in twice, remembers this environment. So essentially, in addition to being the code here, it also remembers that it's in an environment where factor has already been defined. So if it gets, if it gets called, it knows that number is going to be bound to whatever value it was called on, in this case 5. But it also knows that factor, oh, how cool. Wait, I can't click it back though. Well, that's not as cool as it was. Let's run it again. Nice. Excuse me. So if we, oh, no, where were we? Number, vector, remembers the environment. Yeah, that's pretty much the long and short of it. So okay, so the function value it returns, which is stored in twice, remembers this environment. So when it is called, it multiplies its argument by 2. Fantastic. So that's it for this section. Thanks for watching. Hope you enjoyed it, and we'll see you in the next one.